Ever wondered how Kubernetes decide where to place your pods? The answer is Node Affinity. Kubernetes, an open-source system for automating deployment, scaling, and management of containerized applications, uses a concept known as pods. Pods are the smallest, simplest units in the Kubernetes object model that you create or deploy. Now, when it comes to deciding where these pods should reside within the Kubernetes cluster, that's where Node Affinity comes into play. Node Affinity is a set of rules used by the Kubernetes scheduler to determine where a pod can be placed. It's like a map guiding Kubernetes to assign each pod to the most suitable node. This ensures the efficient use of resources, optimized performance, and high availability of applications. So, Node Affinity is not just about where your pods are placed, but about making sure they're in the right place, at the right time, doing what they do best. Now, don't you want to know how to set up Node Affinity in Kubernetes? Stick around. Scene script. Setting up Node Affinity in Kubernetes is a clear-cut process, and today we break it down for you. To kick things off, Node Affinity is established through a YAML file that sets out the conditions for node selection. This file is the blueprint for your pod, and there's a particular field in this file that we're interested in, the affinity field. This field is where the magic happens. It's where you specify the conditions that dictate which nodes your pod can be scheduled on. Now, let's dive into the affinity field. Within it, you'll find two subfields, Node Affinity and Pod Affinity. We're focusing on Node Affinity today, which itself contains two crucial subfields. These are required during scheduling, ignored during execution, and preferred during scheduling, ignored during execution. Quite a mouthful, right? But don't worry, we'll break them down. The required during scheduling, ignored during execution field sets hard rules about node selection. It's like a stern teacher laying down the law. If the conditions you set here aren't met, then the pod won't be scheduled on the node. Period. It's a firm, non-negotiable rule, but sometimes that's exactly what you need. On the flip side, we have preferred during scheduling, ignored during execution. This field sets soft rules about node selection. It's more of a gentle suggestion rather than an ironclad rule. Kubernetes will attempt to adhere to these conditions, but if it can't, it won't stop the pod from being scheduled on the node. To illustrate, let's consider an example. Suppose you have a high memory application. You can use the required during scheduling, ignored during execution field to ensure your pod is only scheduled on nodes with a certain amount of memory. Alternatively, you could use the preferred during scheduling, ignored during execution field to express a preference for these high memory nodes, but still allow your pod to be scheduled elsewhere if necessary. And voila, you have just set up Node Affinity. But wait, there's more to learn. Did you know there are different types of Node Affinity? Let's dive in. In the world of Kubernetes, Node Affinity is categorized into two types, hard affinity and soft affinity. These two types differ mainly in their level of strictness when it comes to rule enforcement. Hard affinity, also known as required during scheduling, ignored during execution, is strict and uncompromising. It dictates that a pod cannot be scheduled unless the node fulfills the given criteria. It's a bit like a stern schoolmaster, insisting on rules being followed to the letter. On the other hand, soft affinity, known as preferred during scheduling, ignored during execution, is more lenient. It's more like a friendly suggestion rather than a hard rule. Kubernetes will try to adhere to these rules, but if it's not possible, the pod can still be scheduled on another node. So understanding these types and their differences paves the way to a more efficient and effective Kubernetes environment. So that's a wrap on the types of Node Affinity. Now, are you ready for a quick recap? So, let's take a moment to revisit what we've learned about Node Affinity in Kubernetes. Node Affinity is a crucial concept that allows us to specify the conditions under which pods are scheduled on nodes within a Kubernetes cluster. It's essentially the rule book, guiding Kubernetes on where to place your workloads effectively. We've walked through the setup process, highlighting the steps to define Node Affinity rules in the pod specification. It's a straightforward procedure, almost like filling in the blanks in a template, but with a significant impact on workload management. We've also delved into the different types of Node Affinity, required and preferred. These types enable us to express both hard and soft scheduling requirements, further enhancing our control over workload distribution. Node Affinity is indeed a powerful tool in the Kubernetes arsenal. It's not just about knowing how to use it, but understanding its potential in managing your cluster's workloads more efficiently. And that's a wrap. Remember, understanding Node Affinity can make your journey with Kubernetes a lot smoother. Until next time, keep exploring.